Hey guys, today I'll be talking about t-distribution, which is a probability distribution that is used to estimate population parameters when the sample size is small or when the population variance is unknown. So t-distribution is given by this following, and it being a density distribution, we find the PDF, that's probability distribution function, density function of t, which is given as follows: f of x is equal to 1 by root n, 1 into 1 by beta n by 2, beta of n by 2 and half, into 1 plus x square by n to the power minus n plus 1 by 2, where x is between minus infinity to infinity, beta is beta function, and n is the degree of freedom. So first we find mean and variance as always using expectation method. So first we get mean, which is e of x, that is equal to integration of minus infinity to infinity x f of x dx. So we divide this into minus infinity to 0 and 0 to infinity. Now minus infinity to 0 can be taken as integration of minus of integration of 0 to infinity. By this we can cancel out the equation and get e of x is equal to 0 when n is equal to 1. So what we consider as mean is only defined when n is greater than 1. So further we get m is equal to mean e of x is equal to 0 when n is equal to 1. Next we get variance v of x, which is equal to e of x square minus e of x whole square. So e of x square is given by this formula, that is minus infinity to infinity, integration minus infinity to infinity x square f of x dx, where f of x is equal to f of minus x is equal to f of x when in PMF for t distribution, and minus infinity to infinity x square f of x dx is equal to 2 0 to infinity x square integration 0 to infinity x square f of x dx. So based on this we simplify the equation, we transform the equation into the following, that is the same thing but 2 0 to infinity, and we expand f of x as follows. Further on simplifying, we get mn by n root n into 1 by beta n by 2 comma 1 by 2, and again the entire process. We separate dx n by 2 into root mn by we put x square by n is equal to m, and this is by substitution. So on differentiating that we get the following, finally resulting in x is equal to root of nm, and that we replace into the equation. N by beta n by 2 beta of n by 2 and 1 a half into 0 integration of 0 to infinity m to the power half 1 plus m minus n plus 1 by 2 dm. So this again is a tedious task, so you will have to be careful while integrating it. It might look complicated, but it's pretty simple. So finally on simplifying it, we get the value for which we get the representation of beta 3 by 2 comma n by 2 minus 1 as given in the equation. So we expand these values with respect to n, and 1 by beta n by 2 1 by 2 is given as the first equation, that is root of first part of the equation, that is root of n plus 1 by 2 by root of n by 2 and root of 1 by 2, and the next is the reciprocal of it. Thank you.